Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I'm part of the database organization here at Oracle. Today, we're excited to show you how to quickly deploy a serverless autonomous database directly from the Azure Portal, connect with your favorite tools like Visual Studio Code, and rapidly develop using modern languages. I'd also like to note that we are recording the webinar, and you'll receive the replay via the same email that you registered with after the event concludes. If you have any questions, we've enabled the Q&A section of the Zoom and we'll answer throughout the hour as well as leave some time at the end for any remaining open questions. Today's webinar will be presented by Matt McDaniel, Staff Cloud Engineer. So without further ado, Matt, over to you to take it away.
Thank you very much, Tara. All right. Hello, everyone. Thanks for joining today's webinar. It's going to be an exciting one today. We're going to talk about how to build smarter apps with Oracle Database 23 on Azure. And today, we're going to go through a number of items here. We're going to discuss at a high level what the service is. We're going to discuss what services are available on Azure today. We're going to dive a little bit deeper into Autonomous Database at Azure, talk a little bit about how the architecture is set up. Then we're going to go into a demo of showing how to provision your own ADB at Azure, how to connect to this ADB, as well as how to develop basic CRUD applications for uh, your ADB. So first, let's go into what the service is. So Oracle Database at Azure is us bringing the Oracle database to Azure. So what this enables you to do is to use Azure Cloud Native Services, things such as Azure's Compute, Azure's Kubernetes Service, AKS, their DevOps service, amongst many others, to integrate with Oracle Database on Azure. So it's not a Oracle database on OCI connecting with applications on Azure. It is Azure applications connecting to an Oracle database on Azure. What this allows you to do is to modernize your databases, your Oracle databases in the cloud. Say you're running Oracle databases on premise and you want to move them to Azure, you can. Also, some enhancement we've made is that we've simplified the purchasing options for Oracle database at Azure. Okay, so exactly what do we offer in Azure today? So first of all, we have our Exadata database service. This gives you dedicated Oracle managed infrastructure for the most challenging workloads and that need the highest performance. This is database optimized compute, networking, and storage running on our Exadata hardware. You will get full control of database management and as well as the control plane with this. Today, what we're mainly going to focus on is the Autonomous Database here on the right. So Autonomous Database is built completely on Oracle Exadata infrastructure. It is fully managed and has automated provisioning. It also allows you to automate patching, upgrades, hardware refreshes, and so on. Similarly to Autonomous Database on OCI, you still get access to all of the different features that you would get on ADB on OCI. Things like Apex, ELT, machine learning, graph, and spatial. Another service we offer on Azure is the Oracle database or base database service. So the base database service is mostly for those who want to run fully managed shared infrastructure, but on a single instance Oracle database. Think something like a PDB today. Generally, this is good for like low cost, general purpose workloads. But you don't get, it's not as expansive as what you'd get with, say, Autonomous Database or Exadata. Lastly, we offer the zero data loss autonomous recovery service. So this is a fully managed data protection service for Exadata database service customers. So this gives you backup automation, enhanced data protection for the most stringent of storage requirements, and so on. Okay, diving a little bit more into Autonomous Database. Like I mentioned before, it gives you automated patching and security. So you do not need to worry about patching your autonomous databases, even on Azure. Security as well is automated. Scaling, just like on OCI, you can get automated compute scaling and storage scaling, just as you would in OCI, along with backups, the provisioning process, the configuration process, and tuning and so forth. So all of this, just like you would get on OCI, is available on Azure today. Okay, how does this look like then? So the sort of the architecture of what ADB on Azure is in the Azure data centers. We have our own child sites, and those child sites are managed by Oracle. All right, sorry for that. So the Autonomous Database is running on Oracle hardware within an Azure data center. So this will give you the lowest possible latency when using Autonomous Database in Azure. So instead of running an Autonomous Database with an OCI and setting up a connection between your Azure account and your OCI account, now it's actually all running within the the Azure account. So you can see here, you could have your applications within one of your Azure VNets, and those can connect directly to an Autonomous Database running within that same data center. Now, to actually show you the demo, today I'm going to actually go through the Azure console and show you how you actually set up an Autonomous Database running in Azure. So the first thing you need to do is actually subscribe to the Oracle database at Azure in the marketplace listings. So if you go to the Azure console, you just search up marketplace. You can see the marketplace application here. Once you click on that, it'll take you to the screen, and then in the search bar, you can just search Oracle and then find the appropriate listing here. In this case, it's Oracle Database at Azure. When you subscribe to it, you have the option to go pay as you go, and then standard Oracle Database at Azure. This is the public offer for um, uh, Oracle Autonomous Database at Azure. But it's very, very simple. You just click on this, you go through the steps here to set this up, and then you're good to go. So once you've done that, what you need to do is you'll see that you have this new service within Azure. It's called Oracle Database at Azure. You click on this, and you'll see we have the services that I was talking about before. So we have the Autonomous Database service, the Exadata database service, and the base database here. So to actually create the Autonomous Database, we click Create an Oracle Autonomous Database. You select your subscription. You select the resource group you would like to use, and then the name of your database. Then you click Next, and then select the configuration. So we have 4 different types of workloads that pertain to different kind of applications that you may want to deploy on these databases. So for instance, we have data warehouse. This is great for BI and analytical use cases. We have transaction processing, which is built for mostly transactional workloads, high throughput. We have JSON, which is a developer-friendly document database, which is a little bit smaller. It's a smaller footprint. It's useful for applications that are mainly using JSON to store data. And then lastly, we have Apex. The Apex workloads this is generally used for applications that are primarily using Apex um, as their front end. Now we select the database version. We support 2 versions of Autonomous Database, 19C and 23AI. Today we're going to be using 23AI. Then you select the eCPU count. So the eCPU can go from 0 to 512, and storage can go from 1 terabyte up to 384 terabytes. We can enable compute auto scaling. What this does is when you have spikes in workload traffic, the autonomous database can scale up to 3 times your eCPU count that you've selected here. So if I had an application and I suddenly got a huge spike, huge surge in customer traffic, my eCPU count will go from 2 up to 6. Would be the maximum here. But I can, if I have 33 here, then that would multiply that by 3 as a maximum number of eCPUs. Likewise with storage, you can also enable storage auto scaling, which similarly to compute auto scaling will scale the storage up to a maximum of 3 times what you select here. Next, we have backup retention. So backup retention specifies the number of days in which you want to store your ADB backups. So you can select any number between 0 and 60. I'll just keep 60 here. Next, we just have to set up some admin credentials. So this will be the credential for, of course, the admin user. And then you can choose the license type. So license included or bring your own license is an option here. Okay, networking. So you have 3 options when it comes to where you can set up the autonomous database in terms of networking. So you can select secure access from everywhere. What this will allow you to do is, well, you can access the database from any address. Um, you will still require credentials, obviously, and a wallet to connect to the database, but this won't restrict any particular IP addresses. You can connect from anywhere. You can choose the managed private virtual network IP only, which allows you to actually specify a particular network in which to locate this database. And then lastly, we have the secure access from allowed IPs, which allows you to establish an access control list to determine what IP addresses and what CIDR blocks can actually access the database. So for instance, here in the IP addresses, you can specify any uh, CIDR block, for instance, if I were to use like this would allow this CIDR block to access the autonomous database. This is great if you need to isolate um, if you want to secure the database and isolate where traffic is actually originating from. This option here, require mutual TLS, MTLS authentication, means that you are forced to use a wallet to connect to the database. So credentials are not enough to connect to the database. You will have to have some sort of wallet in which to authenticate the server and then the client. Okay, maintenance level. So here we have the maintenance patch level. You can only choose regular here. So the database will be patched on a regular schedule. Now we have to set up maintenance contact emails. So this is if there is some sort of unplanned maintenance event or there's a notice or an announcement, this is the email address in which it's sent to. Lastly, uh, just some consent here. You have to agree to the terms of service. And then you can apply tags to the database. And then, of course, we review and so on. I already have a database set up, so I won't actually be going through with this. But I will show you an existing autonomous database instance. wrong one. Sorry. Here we go. Okay. Once the database is spun up, you can see that we have the database here. We can see the resource group it's located in, the location, subscription, the state, and so on. And we can see a bunch of information regarding the backups, the networking, resource allocation, disaster recovery, and maintenance. So if you're saying to yourself, this looks very familiar, if you've used ADB at OCI, you'll notice this is almost identical to what you'd see in the OCI console. So a lot of this stuff is very much the same, which is great because the learning curve is then reduced by a lot, because a lot of this is just the same. It's just in Azure now. Here you can see we have a lot of the same features as well. We can create a clone of this database. On the left-hand side, we can see a number of options here, such as the properties, the disaster recovery, such as, setting up peer databases with DataGuard. We have backups, just like in OCI. We take backups frequently. You can see here we get backups at least daily here. Then we can click on connections here and we can see the connections just like you would see in OCI. This connection is what we'll use to actually connect to the database once I show you uh, in the terminal. We have the resource allocation screen in which you can actually specify the number of eCPUs and storage that is allocated to your database. Last thing I want to show you, and then I'll actually go into the terminal and show you how to connect, is the metrics. So the metrics are within Azure, so you can monitor the autonomous database using Azure tools. So here we can see we have this opened up to the metric screen. You select the scope. Already selected the namespace, your Oracle Autonomous Database, the metric here. So for instance, I can select failed logins. I could see there's a failed login yesterday. That was probably me. The query latency, and so on. A lot of these metrics will look familiar because they're similar to the metrics that you'd find within OCI. Okay. Now, how do we actually work with this database? So we have the database running, but we need to connect to the database and do some work. So to do that, we go to the connections here and we download the wallet. If you're not familiar, the wallet is what is needed to connect to an autonomous database when we're using MTLS. So when you click on download wallets, you have the option for instance and regional, and then you give the wallet a password. So I'll just say, once you type in your password for the wallet, it will download the wallet to your machine. And this wallet just has information regarding, well, the credentials that you're using to connect to the database, as well as connection information for whatever client you're using to connect to the database. So for instance, if I were to show you sorry, my computer is being very slow. There we go. So you can see this is has keys and connection information. Okay. Now let's actually connect to the database and see what happens. So what I'm going to do today is I'm going to use our Visual Studio SQL Developer plugin. So if you're not familiar, let me expand this. We have this wonderful new plugin for Visual Studio Code. Let me see where I have it. Called Oracle SQL Developer Extension for VS Code. Of course, if you still want to use SQL Developer, the client application, you're more than welcome to. The This is just an option for those who want to use VS Code to write SQL queries. It's very slick, it's very nice, it's very modern. It's what I really like about it. Another thing that's very nice about this plugin is that it comes with an MCP server. So if you want to use something like GitHub Copilot and actually interface with your database, you can use this plugin to do that. And I may show that a little bit of that later. Okay. So before we actually connect to the database, we need to do one more thing, and I forgot to show that. That is, we need to download the client for Oracle. In this case, I'm using the Oracle Instant Client. Here we need to download either the zip or this RPM and download the SQL Plus package for that client. The reason being is the first thing I want to do is I want to connect to the database using SQL Plus, which is a command line tool, which allows you to run simple commands, test connections, and so on. So here, once you download that client and that package, you get it all installed. We will then actually connect to the database. So here I went ahead in this terminal, I went ahead and connected to SQL Plus, and we can see that I have connected to this particular database, and I can select, uh, whatever. So here, what we actually want to do is create a new user. I'm connected as the admin user right now. So I'm going to go ahead and create a new user. I'm going to call it ADB-S. Then I'll give it the password. Oh, whoops. Oh, I need a capital letter. Oh no. There we go. Third time's the charm. Then I need to grant some permissions to this user. Let me close out some of these screens to make this less cluttered. Going to grant this role to the user and then grant it unlimited table space just so I can create tables and add data to it. All right. So I've granted these roles to my ADB-S user. Now I can actually log in to that user. So I'll use SQL Plus. And then here to actually tell it to connect to that particular database, we need to use one of the connection strings that was in the console. So if we click in here, we see we have TNS name the authentication and the connection string. Here, I'll just use this TNS name here. This will allow us to connect to the database. Oh, there we go. So I'm connected as my new user on my ADB-S at Azure. And let's see if I can run some queries. Yes, so I can run generic queries, access some data. However, right now there's no data within the schema that I created. So now I need to create a table. So instead of using SQL Plus, I want to use the plugin, the VS Code plugin, to actually uh, run these queries. So here, what we need to do is create a connection for this user. So if you'll see in the plugin, we have this connections tab at the top. We click add, and then a new screen will pop up saying new connection, and we give it a name. Let's just call this Cloud Coaching. We select the role for this particular user, the username. So in this case, ADB-S, the password, the connection type. And this is important because we want to not select basic, we want to select Cloud Wallet because we downloaded that wallet from Azure. Now, what we need to do is select a configuration file for that wallet. So where is the wallet actually located? In my case, it is located in user lib Oracle 23 client 64, and then here we go. Oh, it's a zip file, my bad. Oh, I just can exit out of that, my bad. Select Cloud Wallets, then choose the wallet here. Where did I put that wallet? Okay. In any case, I forgot where I put the wallet, but I do have the connection already running. So I'm going to go ahead and use that instead. So before I actually run this, I'm going to drop this table. Then I'm going to click the run statement. All right. So I've run that. Now I want to create this particular table, and the example I'm going to use here is a sample employees table, which I have the command right here. A very simple SQL statement in which we're creating an ID, a first name, a last name, email, salary, and the primary key. Then I run the statement. And I've created this table using this connection. Now it's time for me to insert the customer data. And there are actually a couple of ways we can do this. I'll show you both. Using a standard SQL workbook, just create the insert statements and then run them. We can see it's inserting the data. I do want to show you one other way we can insert the data, which I find very interesting. That's using the MCP server using GitHub Copilot. So once the data is inserted, I'm going to go ahead and drop it actually. Oops. All right. Now let me show you the MCP server. So in Visual Studio, they have the built-in Copilot chat. And to get this to work with the Oracle MCP server, you would select agent, then select the model you want to use. And I believe it is, yes. And then you would select the MCP server that comes with VS Code. In this case, it's the Oracle SQL Developer extension. Once you do that, you have a number of commands you can run. One of these is list connections. Click allow. And we can see I just wanted to list my connections. If I click on the SQL Developer, you see I have one connection here, which is Cloud Coaching. And then in the GitHub chat, it says there's one saved connection available, Cloud Coaching. If you want to connect to it, let me know. So let's tell it, let's connect to Cloud Coaching. You are now connected to Cloud Coaching Oracle Database. Let me know what query or action you want to perform next. So let's tell it to create a table. So here I'll say, create a table named employees with the following columns: ID, first name, last name, email, salary. And then I'll tell it to make a unique key. Be sure the ID column is the primary key and the value auto-generated on insert. So we're just creating the same table we created using the SQL workbook, but we're using AI to do it instead. All right. The table employees MCP has been created with the following columns. Let me know if you want to insert data or perform other actions. So let's go ahead and do that. So Let's tell it to load 25 rows of sample data into the table employees MCP. Be sure to use real first and last names. Be sure to issue the commit statement, oops, after loading the data. Let's see. Click allow. You can see it's running run SQL. 25 rows of sample data have been loaded into the employees MCP table using real first and last names. If you need to view or load the data, let me know. Well, let's go ahead and do that. Let's just tell it to give us some data. So show me 5 rows of data from the employees MCP table. And I spelled that wrong. And there we go. So it's giving us some sample data here that we just asked for using natural language. So this is just one way you can interface with the database using this VS Code plugin and the MCP server. So for now, what I'm going to do is actually drop that table. And we're going to rerun what I did before because some of the code we've written is reliant on this. All right. So I'll go ahead and rerun some of these queries I did before. All right. So we have the data back in. Now what we want to do is write the code to interface with this. Now, on pretty much any programming language, you can connect to the Oracle database. So we support Rust, we support Node.js, we support Ruby, Java, Python. It, probably missing a bunch there, but there are plenty that we can use to connect to the database. So today, what I'm mostly going to focus on is how you can connect to it using Python. So here I have some sample code. Let me move this chat smaller, showing how we can connect to this database using Python. So here on line 7, you can see I'm specifying a username. I'm specifying a password on line 8. And on line 9, I'm specifying the DSN or the connection string. If you recall, when I was running the SQL Plus commands, I was using that connection string that I found on Azure. Here, this is the link to the client. That client is what I showed you earlier, what I downloaded from the website. Now, this is optional. You don't have to use this client, but it is optional because it does give some nice features. But you can get away with not using this particular client. Uh, This is known as the thick client. We also have a thin client, which doesn't require this installation. So here, this particular application is a very simple CRUD application. It's just connecting to our autonomous database that we created. It lets you view employees, it lets you update employees, allows you to delete employees, and so on. So you can see here, code's fairly simple. We're just getting the connection. We're using this client that we downloaded to connect using our credentials. We have a function to fetch the employees, so just get the employees. We have a function to add the employees, and we have a function to update the employees and delete the employees. We're running this as a Streamlit application, so we can get a nice UI just to show it, off. Okay, so how do we actually run this? Let's go ahead and go into the terminal. One thing you'll need to do is you'll need to install the Oracle DB using pip. So pip install Oracle DB as well as Streamlit. And once you run this, and I've already run it, so I won't show it again, but this will download all the libraries needed. It's fairly simple to download all of this, very self-explanatory. So once we have this all downloaded, we can actually run this application. All right. So now I've run the application. It's being run on my local machine. So let's go ahead and take a look at the application. All right. So now I'm running the application and we can see view employee, add employee, update employee, and so on. So all of these screens, we can see we're querying the data. We can add an employee. And so, oh, wrong button, and so on. So, yep, we can also update employees that we see here. Let's change that. And there we go. So that's just an example of Python. We do have many other examples, and we will actually be sharing these examples with you all for various different programming languages. For instance, we have the DB, or sorry, we have the .NET, in which when you read through this, you'll see that it's actually very similar to the Python, right? We're using the same connection string, in which we're using the username, password. We're using that client that we downloaded in the wallet. We support Go as well, where we have the user, same thing. Specify the user, the password, the connection string, JavaScript, and I won't go through all of these, but you'll notice once you read through these, it's all very similar. Connecting to an Oracle database is very simple, regardless of what database, or sorry, what programming language you are using. All right. Now with that, so this is all part of a lab. So this is all will all be available for you to use. All of this code will be available for you all to download. All of the steps to set up the autonomous database and set up the application, set up the Visual Studio Code plugins, set up the MCP server, connect to an LM. All of that will be available to you all. So you can all use this as a reference for when you are building applications on uh, Autonomous Database running on Azure. So with that, that is the end of this particular demonstration. So I am from the Code Innovate team. So what is the Code Innovate? So the Code Innovate is a hands-on introduction to cloud services. Essentially, what we do is we work closely with your team to develop a prototype of your choosing, depending on use cases that you bring us. So the idea here is we spend an entire week, about 20 hours in that week, actually building a use case that you bring us. Ultimately, what this does is it facilitates rapid knowledge sharing. So our experts on the Oracle side will be able to rapidly train your developers from your organization on how to use services such as Autonomous Database at Azure. At the end of this Code Innovate, we have a fully functional prototype based off of the use cases that you send us. And this is a great opportunity for you all to learn how our services work, how to actually build your applications on our services, and ultimately become very good at using Oracle Cloud Services, and in this case, using database at Azure. To connect with us, we do have an email here, and you can send us an email if you're interested and send us some of your use cases. So with that, thank you all very much. I really appreciate your time. Hopefully you enjoyed this demo. Hopefully you found it useful.
This is an ongoing series, so if you'd like to attend any future events, those can all be found at oracle.com/developer/events. Thank you again for joining us here today. We hope to see you at the next one.
Thank
Thank
you.
you.
Thank you all. Appreciate it.